Okay, this question we are given the following sequence that starts 6, then 2, then 2/3, then 2/9. And what kind of a sequence is this? Well, to get from 6 to 2, you have to multiply by 1/3, right? 2 divided by 6 is 2/3 divided by 2 is 2/3 times 1/2, which is 1/3. 2/9 divided by 2/3 is 2/9 times 3/2 again, which is 1/3. So the common ratio here is 1/3. So from here to here, common ratio is 1/3. Here to here, common ratio is 1/3. Here to here, common ratio is 1/3. So the common ratio is 1/3, and my first term, a sub 1, is 6. Now, what's the next question that I have to answer? We want to find the nth term of the sequence. Now, what's our formula for the nth term? For a geometric series, a sub n is the first term, a sub 1, times r to the n minus 1. That's our formula for the nth term in that sequence, in that geometric sequence, and we want to find the 8th term. So I need a sub 8 would be a sub 1, which is, well, we'll just write it a sub 1 times r to the 8 minus 1. A sub 1 is 6, r is 1/3, 8 minus 1 is to the 7th. So what's that going to give me? 6 times 1/3 to the 7th. A very small number. It's 2 over 729 is what it reduces to. 0.002743 approximately. That's our approximate solution. It actually equals 2 over 729 if you convert that to a fraction. So that is the 8th number in the list. What's the next thing it asks us for? We want to complete the recursive function. The first term is what? Well, the first term is 6. And the next term is how much multiplied by the previous term. Okay, well, the first term is what? First term is 6. So our recursion, our recursive function, a sub 1 is 6. And a sub n, the next term is some multiplier of the previous term. Well, what did we say? We said the common ratio was 1/3. So the next term is 1/3 times the previous term. 2 is 1/3 of 6. 2/3 is 1/3 of 2. So my recursive function tells me a sub n will be 1/3 times a sub n minus 1. What else does it want me to answer? Construct a formula for the first n terms of the sequence. Well, I guess there's 2 ways for us to think about that. First, n terms of the sequence. Remember our sequence was 6 to, 2/3, 2/9, ... First n terms, sum as k goes from 1 to n. And we said the nth term was 6 times, well, we said a sub n is a sub 1 times r to the n minus 1. We know here that a sub 1 is 6 and the common ratio is 1/3. So a sub n would be 6 times 1/3 to the n minus 1. Well, I'm going, k goes from 1 to n, so I'm starting where? I'm starting at 6 times 1/3 to the k minus 1. And notice it'll end at the nth term. The nth term would be 6 times 1/3 to the n minus 1. So that's one way for us to list the sum of the first n terms. So using my preferred notation, that is s sub n, the sum of the first n terms. But also remember, for a geometric series, right, which is a1 plus a1r plus a1r squared plus a1r cubed up to the nth term, which is a1r to the n minus 1. For a geometric series, the sum of the first n terms is a sub 1 times 1 minus r to the n over 1 minus r. So we can actually fill this in then. We want a formula, right, that defines the sum of our first n terms. So S sub n a sub 1, our a sub 1 is 6 times 1 minus 1/3 to the n divided by 1 minus 1/3. So that would be our formula for n terms. Here it is written that way, and we'll try them both as we move on to our next question, which is find the sum of the first 10 terms of the sequence. Okay. Well, what do we know? Sum of the first 10 terms if we use this version, S of 10 would be what? S of 10 would be the sum as k goes from 1 to 10 of 6 times 1/3 to the 10 minus 1. So S, excuse me, 1/3 to the k minus 1. K goes from 1 to n, that gets us to our 10th term. So let me just rewrite that so there's no confusion. S sub 10 is the sum as k goes from 1 to 10 of 6 times 1/3 to the k minus 1. Notice it'll end at 1/3 to the 9th. That's our 10th term. Let's jump to the graphing calculator and see what answer we get if we plug that in. So to the graphing calculator we go. Math 0 summation. Summation is k goes from 1 to 10. K is here from 1 to 10 of what? Of 6 times 1/3. Order of operations here gets tricky. To the, and I need it to the k minus 1, alpha k minus 1. I think I'm still in the exponent there. I should be good. Let's see what number we get using that formula. 8.999847584. We'll just go ahead and use that approximate answer. So it's getting very close to 9. 8.99847.584. But we also have this formula for the nth term down here. So there's our S sub 10, 8.99847.584. We also have this. We also have S sub n is 1 minus, or S sub 10 is what I'm going to need. So this is our current formula. S sub n equals 6 times 1 minus 1/3 to the n over 1 minus 1/3, which I'll just cheat and say 2/3. But I want 10. I want 10 numbers. So what is the sum of the first 10? That would be 6 times 1 minus 1/3 to the 10th over 2/3. This is going to be challenging to do on the graphing calculator, getting the syntax correct, but I will try. So let's go back to the graphing calculator again. I think I'm going to try it this way. 1 minus 1/3 to the 10th. I just want you to see what I'm doing here, and I'll do some more stuff with this. So that was the numerator. Okay, 1 minus 1/3 to the 10th. I want to multiply that by 6. I want to divide it by 2/3. So here I am. Can I multiply it by 6? Sure, second insert. 6 times So I multiplied that top by 6. See what I have? 6 times the top, now divided by 2/3. That's what we need next, right? 6 here times the numerator divided by 2/3. I'm going to come back to the end. We're going to divide that by 2/3. Divided by 2/3. In parentheses, 2/3. Because again, order of operations becomes an issue with the calculator. We hope we get that 8.999847 stuff. And we do. So they agree completely, which convinces me that I set up the formula correctly. 899,847,584, which is good. All right. And what else do I have to answer on this question? Determine whether related geometric series converges or diverges. Well, so if it converges, that means if we add it up to infinity, we're going to get a single solution. So what do we know here? Here is our series, right? 6, 2, 2/3, 2/9. 6, 2, 2/3, 2/9. It is geometric. The first term, a sub 1, is 6. The common ratio is 1/3. If the common ratio is between -1 and 1, the geometric series converges. So this converges. Therefore, this series converges. What does it converge to? The fact that we had 8.999 may give you a hint. So the infinite sum is the first term divided by 1 minus the common ratio. The infinite sum is the first term, 6, divided by 1 minus 1/3. What is that going to give me on my calculator? Let's take a look. 6 divided by parentheses 1 minus 1/3. And what do we get? We get 9. So interestingly enough, these numbers you see here, 8.999, from 1 to 10, it's awfully close to 9. So if I go 1 to 100, imagine how close it will be to 9. Math, summation. Let's go, k goes from 1 to 100. It's not infinity, and 100 is not infinity. And you also run the possibility that you are going to upset the calculator and get beyond its tolerance. But let's hope it gives us a decent answer here. 1/3 to the k minus 1. We expect it to be very close to 9. It may give us 9, but it's going to take a while for it to add all those up. And sure enough, it gives us 9, but it's not really 9, it's 8.999 and a whole bunch of 9s. And that's it.